In this video, we're going to define conformations and then look at how we can use Newman projections to represent them. So conformations are different arrangements of atoms that are interconverted by rotation about single bonds. So two extremes of conformations for the molecule of ethane are one, eclipse, where if you're looking at it from the front to back carbon, those hydrogens overlap each other. And then there is also the staggered conformation where the hydrogens are as far apart from one another. So let's look at that in two different ways of modeling it. One is, let's actually look just at our space-filling ball and stick model. And so this is looking at the orientation from that front carbon to the back carbon. And this is an ethane molecule in the in the staggered conformation, where the hydrogens can be as far apart from each other as possible. So let's look at another model. So here is a space-filling model of ethane where the carbons are in the center again. Each carbon is bonded to 3 hydrogens. And so try to notice that the ethane is spending most of its time in the staggered conformation, and every once in a while it will manage to be eclipsed as it rotates, but it kind of just goes back and forth, rocks back and forth quite a bit. All right. So that end-on representation, like looking at the ethane molecule like this, just look at it from the side. If we look at it end-on, like there's a carbon in front and there's a carbon behind. This projection, or this way of looking at a molecule, is called the Newman projection. And what you kind of want to imagine is that somebody cut a disk out of a piece of paper and put it on the bond between the 2 carbons. So you really can't see the carbon behind the first carbon. So when we draw Newman projections, we draw the carbon that's in the front as just a little tiny dot. And then, like I said, there's like this disk that you somehow just put on over the bond that blocks a little bit of the carbon-hydrogen bonding in the back. And then you can't see it, but there's another carbon, the second carbon, that one, in the back. So this is being drawn in the staggered conformation. Each of those hydrogens from the front are, there's 3 of them coming off, and then there's 3 in the back in the staggered position. And then you can add the atoms onto each bond. So like I said, with the ethane molecule, there's 2 conformations that are kind of the conformations that we look at mainly, one at 60 degrees dihedral angle and the other at 0 degrees dihedral angle. And those are the staggered and eclipse conformation. In larger molecules, you end up with additional types of conformations. And so with butane, for example, the methyl groups, when they're 180 degrees apart, as far apart from each other as possible, we call that an anti-conformation. They can also be 60 degrees apart from each other, and in those cases, those methyl groups are called gauche conformations. If you do have access to a molecular model kit, it can be really useful in helping to visualize the Newman projections.